Welcome everyone to the Industry Leaders panel at OC3 2025. I'm Felix Schuster, CEO of Edgeless Systems. It's fantastic to be back this year for another discussion with some of the most influential minds in confidential computing. We're here to tackle the big questions. Where do we stand today? What's driving adoption of confidential computing, and what's next? And to break it all down, we again absolutely have an all-star panel of industry leaders. Let me introduce to you, joining us for the first time this year, Daniel Rohrer, VP Software Security at NVIDIA. And joining us all three for the third time in a row, Greg Lavender, Executive Vice President and CTO at Intel, Mark Papermaster, Executive Vice President and CTO at AMD, and Mark Russinovich, CTO and Technical Fellow at Microsoft Azure. Wow, what a lineup. Gentlemen, welcome. It's fantastic to have you here. And just to remind everyone why the companies these leaders represent are so crucial to confidential computing, here's a quick rundown of industry-changing firsts. Intel was the first to add confidential computing to CPUs. AMD pioneered confidential VMs. NVIDIA brought confidential computing to AI accelerators, opening the door for confidential AI. And Azure was the first to bring confidential computing to the cloud. These companies aren't just part of the movement, they are defining it. So we really have the biggest innovators in the industry here today. And let's get started. As some of our viewers may recall, last year, the discussion revolved mainly around confidential AI. And of course, a lot can happen in 1 year. So the first question I want to ask to Mark Russinovich is confidential AI still leading the discussion, or have new trends emerged in confidential computing?
I think that confidential AI is leading the discussion. Confidential, AI is still exploding. It's still on an exponential growth path. People are finding new ways to use it. The capabilities continue to expand. We're into agentic AI, and the concerns around data and protection of IP still remain and are actually getting more serious as more companies get involved and understand the risks that AI poses, especially AI that is processing the most confidential information. You see strives by other companies, including Apple, to try to offer some confidentiality for data as it's being protected for consumer scenarios. In enterprise scenarios, of course, everybody is concerned with the protection of their data.
Yeah, absolutely. That makes a lot of sense. So let's take a look at the big picture and talk about real-world impact. Where's confidential computing actually making difference today? Daniel, what are the most exciting use cases you're seeing, be it confidential AI or elsewhere?
I mean, certainly confidential AI, to echo Mark. And I think, in terms of some macro transitions, what I find interesting or maybe notable is investments in confidential containers. I believe Red Hat published recently their OpenShift efforts. We've obviously been invested in Kata Coco, but NVIDIA's very focused on sort of enabling the market, and certainly Azure we partner with a lot, and sort of enabling GPU within the cloud and others. And we're very focused on sort of how do we make it easier, more accessible. And for many, the AI native stack is containerized, right? And the CVM lift for a lot of commodity AI applications was actually a real burden. So it's exciting to see that transition, those capabilities come out to really simplify the deployment models for a lot of applications that should be pretty straightforward to migrate into a confidential context today. And I think that motion in particular is going to be really interesting on the heels of agentic as well, where we're seeing a lot more different and diverse computing models collected together to go drive those workloads.
Danny, do you see it more for training or more for inference, or both?
Certainly inference, I think, is the dominant proportion of workloads. There are obviously lots of organizations who train very large foundation models with very sensitive data. Confidential computing is interesting there, but I think there's inherently a scale problem. We're seeing solutions like protected PCIe to sort of work around some of the corners of that. Again, areas that we partnered with the major CSP players to provide. But inference definitely seems to dominate. We're excited about the Blackwell transition for us. That's definitely giving us a lot more scale, both because of the encrypted NVLink compute capacities that come with that, but we're also seeing, our partners in in Intel and others really focusing around the compute offload to make the CPU to GPU enclave interactions much more efficient, and again, leading to that scale and those solutions there.
Yeah, I'm looking forward to that NVLink encryption. Absolutely, yeah. So maybe a question to the other participants. What are the most exciting use cases you're seeing right now?
That's Greg. I'll go. I think we're starting to see appliance vendors, Cohesive was for storage appliances, Fortanix for security appliances, adopting confidential computing in their platforms. So these things are embedded, in the enterprise, around the networks. And so I think having confidential computing actually is providing your infrastructure. Confidential computing is going to be much more interesting to chief information security officers and CIOs as we penetrate more into the enterprise market. So I think the cloud has broken the glass and showed what's possible and the capabilities and proven the technology is for real. And Azure has been leading the way. GCP is now production. IBM Cloud, I think, still in preview. Alibaba's in production. So I think the cloud vendors are, as usual, kind of breaking the ground. But I think the enterprise a little bit slow getting there. It's taken some time to get everything uploaded into the upstreamed into the Linux community. But as it's filtering down into the major distributions now, I think we're going to see much more wide deployment, particularly at the edge and in the enterprise.
I'll just add on, part of the reason why we're certainly seeing the cloud as the first adoption is just low. It's just such a low barrier to adoption. I mean, it's literally, clicking a configuration, and the rest is largely taken care of for them, and the lower barriers to manage the keys, to attestation capabilities, et cetera. It's quite straightforward. And so I think that's, it's a multitude. To answer your question, Felix, we're seeing more and more use cases starting in the cloud because it's an easier deployment model.
That makes a lot of sense. And that leads me to the next question. Mark Russinovich, your perspective from a cloud service provider, what's your take on where we stand today with regard to maturity of the technology and the offerings?
Well, so last time we talked, we had confidential virtual machines. We launched with AMD. We launched confidential virtual machines now with Intel. We've got confidential containers with policy in Azure as confidential ACI. So those things existed a year ago, and they've matured somewhat in capabilities. The hardware's gotten better every generation. We're seeing decreases in performance and minimization of impactful updates. We've got live migration within sight now. So these kind of steps to make confidential computing really mainstream and equivalent in capabilities and performance to non-confidential virtual machines. We're also got line of sight to be able to mix virtual machines and non-virtual machines in the same servers, which will really allow us to scale it worldwide because you won't have to segregate capacity. So those are exciting developments that have been progressing. Now you have confidential clean rooms launched in public cloud providers, like we announced a confidential clean room service in Azure in November. You also now have confidential AI as a service in public clouds. We announced confidential inference with OpenAI Whisper, and that in September. And we're planning on launching, and this is with NVIDIA H100 single GPU models supported today. And now we have protected PCIe coming, and that will allow us to launch full node models, so up to 8 GPUs models, which will allow us to run some of the even frontier now generative AI models confidentially. So we're hard at work on that. So those are some really exciting developments since last time.
That sounds very exciting indeed, yeah. So, of course, innovation alone isn't enough. Widespread adoption should be the real goal. Mark Papermaster, what do you see as the key elements in accelerating adoption for confidential computing?
We've been now, as actually 4 years ago that we launched our support for virtualized machines with confidential compute with AMD's secure encrypted virtualization with secure nested paging for these virtualized applications. But then what we followed was really getting that upstream. So if you look at Linux 6.11, it became the first confidential compute out there in KVMs. And so why did we focus on that? Again, just lowering the barrier to adoption. And what I see next is really important is just as we start to expand on different encryption key schemas that and providers that we can use, and we're fully supportive of multiple attestation services. And so I think it's important to have flexibility for customers, and then of course widening out applications. So Daniel talked about confidential AI. That takes an ecosystem. So to have confidential AI, that means that we all embrace standards like Trusted IO, TDISP, which we have supported in our 5th gen Epic server. And so I think it's about getting more and more solutions around that. So we were happy actually to participate with NVIDIA on some of the early applications there. This is an ecosystem. When it comes to security, we all have to play together here. But we've got to continue standards, choice, lowering the barriers to deploy. And if we can do that, I think we're just going to see, we're just at the beginning of this era of confidential compute, because I think we're going to see a knee of the curve.
So you
And I think-
mentioned yeah, please go ahead.
I was going to say, we have a very heavy CPU and compute, party here, but I would definitely echo the ecosystem motion there, and you can see sort of telegraphing out even sort of CC ideas into networking and storage and other things, and really looking sort of a comprehensive end to end, which brings in all the communication fabrics. And TDIPS doesn't just have to be a CPU GPU thing. It could, it's at the PCI root port. Lots of other things can participate under those models, and seeing that and all the way out to the edge, as well as data center servers. I think we're going to see a very rich sort of ecosystem of CC enabled platforms, obviously bringing those applications there as well.
So you mentioned TDISP a couple of times. How is the industry working together to bring that to life?
Yeah, it definitely solves a lot of interesting IO challenges, depending. Certainly, there are workloads that are sensitive to that particular IO branch in the compute graph, and just bringing that down, making it more accessible, allowing more workloads to run without sort of choosing between the security model versus the performance model, and just being very uncompromising. I think, Mark, you said a year or more ago, everything should just run CC natively. That's just the default, right? And I think we're all committed to sort of building an ecosystem that can achieve that.
Yeah, I'll add just one dose of realism, and it goes back to the ecosystem comment. I think what's important is to build the number of supported solutions, but also come together on the standards so that we take the learning in and make the modifications to make sure that we're making it easier, and in fact to not have performance penalty with CCs.
I would add, our goal ultimately should be it's just built in. It's always there. It's always on if you want it, whether it's in a container, a VM, an edge device, etc. That workloads, through whatever CI/CD process gets deployed into an environment, is just as confidence computing as a service. You just select the tick box to sort of provision that particular capability as a feature. And I think, we're getting close to that, certainly in the cloud. And I think, in the edge use cases, I think because of the explosion of vRAN, AI at the edge, RAG inferencing at the edge, you're going to see a lot more demand and application of software workloads that are confidential computing enabled at edge devices, whatever those devices could be. They don't need to be GPUs. They could be CPUs. And it'll just become more ubiquitous. And that's really going to be the scaling function that's going to drive this into wider practice, because your laptop's an edge device, not just something embedded in some telco network or in some industrial IoT edge system. So I think once that becomes ubiquitous and the software is already enabled and ready for it, then we have wide-scale confidential computing from cloud to edge, cloud to data center capabilities. And I think that's what we're going to be there faster than we have. We made a lot of progress to date. It's going to accelerate, I think, quite dramatically over the next 2 years.
Okay. So,
Felix, to talk a little bit about the continuing maturation. So Microsoft's moved its payment systems 100% into confidential computing. I think this happened around the time we met last time. And then we've also are well on our way to fully migrating. In fact, it's going to be completed in the next month or two, all of our signing services from Entra and our consumer signing services into confidential virtual machines. So this is us just adopting confidential computing inside of Azure itself. And it's a plan of record to move the entire infrastructure of Azure to confidential computing with the prioritization for those security sensitive services and our trusted computing base in Azure. We're also, I think, talking about the maturity of confidential computing and expanding from it's just put the code inside of a virtual machine to confidential computing's promise to secure software through its whole life cycle. So confidential build services with immutable records of the builds to confidential signing services with immutable records of the signing. So, which ties everything together. And I've been talking with Mark Papermaster, for example, about even taking that back into, of course, firmware, but even deeper than that, into silicon.
Oh, wow.
We have provenance all the way through the supply chain, from the foundry all the way to bits running in a cloud.
That is very
I
interesting.
can comment on that just very briefly. So this started from a conceptual conversation. Mark and I, probably about the last time we did this, this get together. And what we've done in the last year is we've actually got a proof of concept of taking, this capability from a secure lifecycle right down to the silicon. And so we've just started an effort in combination with a SEMI organization as well as NIST that's just getting off the ground to establish that silicon provenance. And people don't realize it, but that it will be an essential element of confidential compute, because despite everything else we do, if you don't have the assurance all the way down to the silicon. So yes, it's root of trust and the things we've done in standards like Calyptra, but it's right down as well to an attestation of immutable records of every aspect of the component. Very exciting.
Yeah, we're a little off the track of your question here, but I think I wanted to say something that excites me too, and that's interesting about confidential computing, because when you talk about this supply chain provenance we've been discussing, confidentiality is not required for that. It's nice to have, but in many cases, it's not a requirement. But what confidential computing gives you is integrity and attestation. So those two elements alone are what provide this kind of forensic provenance across the supply chain.
So I'm delighted to hear the signing thing, because we're doing the same thing inside NVIDIA for all of our signing for provenance. We're seeing standards where a number of parties on this audience through COSI and others on supply chain control, strong provenance claims. There's efforts in OpenSSF for model signing, where we'll launch model signing. You'll see that NVIDIA has adopted this for all published models that we publish to NVIDIA. They're signed, and you can chain that hardware to container, to model inside container, to response from container, et cetera, and really building a very rich element of claims all the way through an ecosystem.
That makes perfect sense. I think this is how it should be done. Yeah, that's
Absolutely.
great to hear. And I love the news about the silicon provenance. That's exciting, and I can't wait to learn more.
I just add that the financial services industry, I talked to them. Both Marks talked to them. They care a lot about this. Even when I was at Citigroup a few years ago, we would randomly select parts out of the supply chain and degauss them for malware and things like that. We found stuff. But I think all the OEMs have gotten a lot better, and certainly the CSPs have gotten a lot better about making sure that whatever is deployed into production, right, has gone through an analysis at a very minimum of the quality of the firmware, the components of the motherboard, et cetera. So this has been being done, certainly in the government as well. They call it trusted supply chain. And so I think it'll ultimately become procurement requirements for anybody selling into the government. So we all have to address this as an industry.
Thanks for that. Greg, I have another question for you on my sheet of paper here. That's a bit different from what we had discussed so far. It's about quantum computing. So we've been hearing more and more about breakthroughs in that area lately, and actually I'm being asked by customers also more and more how confidential computing may be affected by quantum.
Yeah, so I mean, quantum computing is a broad topic. Is quantum optics. There's different types of quantum computing depending on the type of qubits that are being manufactured to represent the physical qubits and then the logical qubits on top of that. I think there's probably a more near-term sort of thing we have to do, which is essentially just upgrade our encryption algorithms that are currently used in our devices and be post-quantum crypto ready, as people have talked about now for several years in the industry. I mean, at Intel, they just recently launched the Xeon 6, known as Granite Rapids servers. We upgraded to AES 256 encryption, which gives you, more bits in your keys, so that you basically have better encryption capability. And we've got this in support of our TDX and STX technology in our Xeon 6 products, which we've just launched, so that you have a larger key links, which really helps. And then we have this called Quick Assist technology. It's actually used by Microsoft. It's an encryption offload processor, so it's hardware accelerated, and that's also got this upgraded encryption algorithm. And that helps improve your post-quantum crypto readiness. But getting the actual crypto algorithms that are being standardized or have been standardized by the NIST, I think that's going to take another generation of to get there. And but we're all working on it as an industry to get there and get to this FIPS 205 Sphinx standard for digital signatures is important as well. So both NIST, the ISO, the Organization for International Standards, and the IETF is driving this. And so, the algorithms are well defined. In fact, Intel contributed one of the algorithms into the post-quantum crypto standards at NIST. And so it's in our roadmap plan. We'll have it into the product next year.
Okay, that was thorough. Thank you, Greg. Thanks for reassuring me and hopefully also the audience. I think we really covered a lot here: trends, challenges, adoption, and even quantum computing. But for the last question, let's zoom out and look ahead. I'd like to ask every one of you the following question. Over the next 12 to 18 months, what will be the single most transformative breakthrough in confidential computing?
I think first and foremost, it's not just about text anymore, right? We're seeing a lot of growth in multimodal and much more capable AI model scales, which will certainly drive scale at compute level. And we talked about that, earlier. Blackwell hopefully will scale very nicely. We're partnered with all of our CSP partners to get that out into market as quickly as possible. I think that's really empowering for enabling what I think is the other part of the question, which is really these agentic flows. And what I find interesting when I look at the model for agentic flows, typically when we talk about compute scale out, we're looking at sort of homogeneous scale out questions, right? But when you look at agentic flows, now you have a bunch of heterogeneous collaborating parties. And not only do I need to scale compute, but I need to scale trust, right? How do I establish trust and trust relations? And again, sort of that leaning into those attestation primitives to build out mechanisms for negotiated trust between my travel bot, my signing bot, my payment system bot, who may not at time zero actually trust the other person, but they're all trying to execute in collaboration a work plan that the user very casually wrote into their assistant bot on their desktop and is trying to coalesce these capacities across the globe, maybe not even all co-located, to go affect an outcome, right? So I think there are really interesting properties that will emerge in the agentic spaces. There's a lot of delegated authority and things that are transiting in that. And that's going to need scale, leaning into the commentary earlier, having some common standards to transit trust, quantas of trust, claims, whatever, I think will be an interesting architectural evolution and just how we build software and agents in the future. Really exciting times.
That sounds exciting indeed. Thank you. Mark Russinovich, you want to go next?
Sure. I think you asked for one, but I have to say two. And the one is a broad one, and it touches on everybody here, and that is hardware will actually get to the point where it provides the same capability as non-confidential hardware in terms of the things I talked about earlier. That's happening in the next 12 to 18 months. You'll have live migration, you'll have zero impact updates, you'll have TDISP and accelerators that span multiple servers, not just a single server. All of that's coming in the next 18 months or so. And the other one, of course, I think is you're going to see more and more services like the ones I mentioned earlier that are providing, what Mark highlighted is required really to scale confidential computing is just confidential computing as a service, is confidential computing as a checkbox, confidential computing as something I can easily adopt, and you're going to see more services for confidential multi-party computations, including AI, including building on top of the hardware that's coming. to really mainstream it and take it into you can do confidential computing with anything, especially certainly in AI, fine tuning, training, inference with large models and multimodal and agentic models, like Daniel was talking about. That's what you're going to see.
Can't wait for that. Yeah, thank you. What about you, Greg?
Well, I think, and probably like the rest of you, when I go out and talk to customers and I say the words confidential computing, this where their eyes kind of go glaze over a little bit. If I change my language and I talk about privacy preserving, it's a different dialogue. It's the same technology, but privacy preserving talks more to the value that you're creating and the outcomes they can achieve. And I think the best use case of this right now is federated learning. And there, we did an example with University of Pennsylvania, Perelman School of Medicine, where they were doing a brain imaging study of glioblastoma tumors taken from MRI machines. And we did a project with 50 institutions, 71 different locations around the world, where they didn't share their data. They took their training information and they shared metadata about it, and then everybody was able to basically augment their own local training with that metadata, and they could improve the efficacy of inferencing for true positive image recognition by 33%. So this gives a better way to basically get a more definitive analysis done. Imagine getting a false diagnosis. You go home after you got a false diagnosis, and they call you later after they ran AI and said, "Sorry, we were wrong. You're okay. Okay, you're really happy." But I think this idea is really going to mature a lot. And we also did a project with the space station where they were collecting blood samples every day from the astronauts that were up there over extended periods of time, looking at the exposure to cosmic rays. And then they were doing training on the ground station, and they didn't want to transmit all that data back and forth to the space station, so they were able to do federated learning and basically get the analysis and the inferencing that they wanted to do. So I think there's new ways of doing learning in a distributed fashion without having to share all your data, and that's privacy preserving because you don't want to have confidential data, patient data, to go leak out to somebody else. So I think this is an emerging area that really captures the attention. When I start in banking, people start thinking of all different ways they could do that in banking, credit card processing, et cetera, et cetera. So I think we're the geeks. We like to talk about confidential computing, SEV, TDX, PCIe Connect, whatever we're going to do. And we're delivering all that as an industry. But I think we got to really sort of get people to realize that the applications and the social and business benefits are that just make it ubiquitous.
That makes sense. Thank you, Greg. So Mark, Papermaster,
yes.
The last. I hope there's something left for you.
The thing I guess I would add, when I think the next 12 to 18 months, we're going to see on the basis of the trusted I/O standard, we're going to start to see the build out, through the network, through more endpoints, through storage. I mean, again, until you have that, you really haven't established that trust for the privacy of the data. So I think that's going to be a big inflection point, and there'll be more standards. It needs to be, confidential compute with TDISC will be built in things like Ultra Ethernet Consortium for scale out, Ultra Acceleration Consortium for scale up. So I think we've arrived at the point where security and confidential compute is top of mind and is going to be, built in to our ecosystem build out in the next 12 to 18 months. It is an inflection point.
Awesome. Thank you so much. I think if there's one thing that we learned today, it's that confidential computing is no longer just an emerging technology, but it's becoming rapidly enterprise ready and also must have across industries. So a huge thank you to the four of you, Mark Russinovich, Daniel Rohrer, Mark Papermaster, and Greg Lavender. Thank you so much for sharing your expertise and insights today. And of course, thank you to all of you watching this, be it in person in Berlin, or if you're tuning in online. The conversation doesn't stop here. If today's panel sparked new questions or ideas, let's keep the discussion going, whether in the hallways, on social, or at next year's OC3. We're just getting started. Thank you. Until next time.